carbon. What two elements do you think are in a hydrocarbon? Right there. Yep. Which we saw in the homework. And what did you always add to that? O2. And you produced CO2 and H2O, right? And that's one of 5 types of reactions. So I need to talk about the other 4 today. And I'm going to intro just the other 4 and teach you so that you can recognize the other 4. Good? Okay, so here we go. After combustion, there's going to be synthesis. Leave some space, maybe 2 or 3 lines. Decomposition. Leave a couple of lines after that. Then there's single replacement. And there is double replacement. And I'm going to give you like the simplified version of what these each look like, and then I'll give you like an example or two. Good? On tonight's homework, you're going to be balancing reactions, something you've been doing for about a week and a half now, and you're going to be writing down what type of reaction you have. 1, 2, 3, 4, 5. Let's look at a synthesis example. Where A represents a single element or a very small compound, B represents a small element or a small compound, and AB represents a compound. Because we know that compounds are made of 2 or more elements, and we see 2 or more elements in that. And then I'll give you an example with some real chemicals. Good? Here's one that was on your quiz the other day. Ca plus Br2. Cool? Do you remember what this made? Calcium bromide, which was CaBr2. Remember that 2 at the end of Br in the CaBr2, the 2 that I'm pointing to right now, came from a 2 plus on carbon, or calcium. How many products do you see in this synthesis reaction? 1 product. So synthesis always has 1 product. 1 single little product.
So it's always going to be just 2 elements?
Yeah, or 2 very small compounds. So 1 product. Did we catch that? What's the 1 product in this case? Can you do a squiggly line under the 1 product for me? Squiggly line. It's a line that squiggles. Should have put your squiggly around him. CaBr2, right? Cool? Decomposition. This actually is the direct opposite of synthesis. So to be opposite of synthesis, I would have to reverse it. So watch what I do. I take AB, and I produce from that. What do you think? Very good. A plus B. I'm breaking down that compound now. Now, what is there 1 of in this case of decomposition? 1 what?
Reactant.
1 reactant. Very good. That's because it is direct opposite to synthesis. 1 reactant. Maybe you might want to have like a cute little note off to the side. So a double-sided arrow like this. And you might want to say that these 2 are direct opposites. I think that might help out in understanding. So, I'll tell you what, why don't you write down the calcium bromide example, the correct way for decomposition real quick. So I want you guys to write down an example using the calcium bromide example from above, right down here. Remember, they're direct opposites. Is that what y'all got? Because they're direct opposites. Like, let's say I was going northbound on 75 to go to Oklahoma. Weird, but let's just say I did it. What would the opposite be? To go southbound on 75, right? Direct opposites. Now let's look at the next two, single and double replacements. In single replacement, watch this. Remember that A stood for like an element, and then BC was a compound. So you have an element plus a compound, and you produce an element plus a compound. But recognize that everyone here is different. The element that was on this side is not the same as the element on this side. Do you understand this principle? It's like you had a relationship between B and C. A walks in, now A kicks B out, B's gone, B's now all alone, and A and C are together. Right? So this would be like B and C are dating, now A and C are dating, and B was kicked out. Cool? But this is chemicals, so keep that in mind. And it would make sense that metals can replace metals, non-metals can replace non-metals. So the Li here replaces the Ca because Li and Ca are both metals. I could balance that out with a 2 and 2. Do you see how you have a compound and one single little element? Cool. And then in double replacement, you're going to take single, but you're going to do single twice. Do you see how you had one breakup here and one new relationship? Do you see that? Now we're going to have two breakups and two new relationships. Let's take a compound here. Compound. Compound. And compound. But are any of these four compounds the exact same? Yeah, one couple, two couple, and now there's two new couples at the end, but they're not the exact same as they were before. These are the reactions you've been doing, you just have never done it. We haven't called them by names yet. Here's a good example, or at least a good looking example of one that's double replacement. Li was with NO3, Na was with Cl, and now Li is with Cl, and Na is with NO3. Do you see the swap that's occurred? Li is now with Cl, where it was with NO3 before. There's your 5 types of reactions. And let me kind of just show you your homework a little bit. You don't have this yet, but this is what it looks like. What type of reaction, and then that's, you can bounce this later on your own, that's fine. What type of reaction, though, are we looking at in question 1? Double replacement. And we know that because we have a compound, then another compound, and it looks like Na ended up with O and Pb with NO3. See that double swap situation? Nod your heads. Yes, I do. Okay, double replacement. How about the next one? AgI with Fe2CO33 and then FeI3, Ag2CO33, or CO3, sorry. Another double, yeah, right, because Ag is now with the CO3 and Fe is with the I, so I've got another case of a double replacement. Cool? How about C2H2 or H4O2 plus O2CO2H2O? Yesterday's reaction type, the combustion. Because you see CO2, H2O is being products of a burning with O2. Cool? So your task, of course, is to balance these. That's fun. And then also to write down the types of reactions, front and back, 1 through 18. That's your homework, okay? Okay. Awesome.